Hi students, today we are taking a topic acidic strength of organic compounds. Regarding this topic, we are going to discuss about the relative acidic strength of different type of compounds having different functional groups, and among the same functional groups which one has a higher acidic strength, and what is the factors which influence the acidic strength. In this first part, we are going to discuss about comparison of acidic strength of alcohols, and next one is phenols, and then carboxylic acids, and hydrocarbons, and active methylene groups, These hydrocarbons includes aromatic compounds also. So this is I am segregating all the organic compounds into 4 parts: acidic strength of alcohols, acidic strength of phenols, acidic strength of carboxylic acids, and their relative comparison with alcohols, phenols, carboxylic acids, and some of the hydrocarbons why more acidic, and what about the acidic nature of the active methylene groups we are going to discuss. These 3 parts are very important for JEE mains and JEE mains and NEET examination and BITSAT, and this part is very important for JEE advanced. Today in the first part I am going to discuss about the alcohols and phenols. Let's see the acidic nature of alcohols. Students, take alcohol. This is the alcoholic compound. Generally, why a compound will show the acidic strength? Generally, any compound has the ability to produce the H plus ions by dragging its sigma bonded electron density. That shows the acidic strength. That means more polarity is required. This oxygen is more electronegative, that's why it drag the electron density and form the RO minus and H plus. So this is the reason for showing the acidic character. Here this is a alcohol and this is the alkoxide. This is the alcohol and this is the alkoxide. Student, if you observe, this oxygen is more electronegative and this bond is more polar. As a result, oxygen drags the electron density and liberate the H plus. The substances which liberate the H plus will act as an acid. But alcohols are weak acids. Why the alcohols are weak acids is OH bond is a polar bond, but the alkyl group which is present on the OH group is a plus I effect causing group. It is an electron donating group. As a result, electron density on oxygen atom will increase. This increased density will decrease the polarity of the OH bond. As a result, this oxygen is unable to drag the electron density from the hydrogen. As a result, its tendency to liberate H plus ion will increase. So, alcohols are relatively less acidic but less acidic than water. Alcohols are less acidic than water. How we will compare? HOH. Here is OH is there. Here also OH is there. Here some polarity is there. Here polarity is there. But alkyl group is a electron donating group. H is not an electron donating group. So here the electron density will not rise. So this oxygen will drag the electron density and liberate the H plus more quickly than the alcohol. That's why alcohols have the lower tendency to donate the H plus ion than water. So alcohols are less acidic than water. This is the first conclusion. Even though alcohols are less acidic, among the alcohols, which alcohol is a stronger alcohol? Students, here I am writing methyl alcohol, a primary alcohol, a secondary alcohol, and a tertiary alcohol. Here I am writing. What is a primary, secondary, tertiary? I think all the students are well known about this one. Here OH group is there. This OH group have some polarity, but this methyl group is an electron donating group. Because of this electron donation, here the electron density on oxygen atom will increase. If electron density increases on the oxygen, its dragging capacity of the sigma bonded density will decrease. Come to the primary alcohol. When compared with this methyl alcohol, here one more alkyl group is there. More plus I effect will operate. Come to here, more and more plus I effect will operate. Come to here, tertiary alcohol, more and more plus I effect will operate. Whenever the electron density on the carbon increases, automatically it donates this electron density to the more electronegative oxygen. Then this oxygen has less affinity on the sigma bonded density of the hydrogen. That's why it has lower tendency to release H+. Among all these compounds, methyl alcohol has more tendency to donate H+ ions by dragging the electron density. So when you compare these compounds A, B, C, D, which one has higher acidic strength? Undoubtedly A has more acidic, then B, then C, then D. What is the simple reason? Here one methyl group is there, here one more alkyl group is there on the methyl group, 2 alkyl groups are there, here 3 alkyl groups are there. More is the number of alkyl groups, more will be the donating capacity. More is the donating capacity, electron donating capacity, then polarity of the OH bond will decrease. So tendency to lose H+ ions will decrease. So among all the alcohols, tertiary alcohol is a weak acid and methyl alcohol is a strong acid. Now we are going to compare the substituent effect on the alcohols. Students, to explain the substituent effect on the acidic strength of alcohols, here I am taken 3 examples. Here OH group is commonly there in all the compounds and the number of carbons in the parent chain is common. Of course, here the substituent is, let it be NO2, here is the CH3, here is the NH2. Actually, it is a ethyl alcohol, it is a isopropyl alcohol derivative, it is a ethyl alcohol derivative. Among these alcohols, which one is more acidic and which one has a higher Ka value, which one has a higher pKa value? I think all the students are well known about pKa is equal to minus log of Ka. Ka is the acid dissociation constant. Ka is more, acidic strength is more. If Ka is more, pKa value is less. Let's see which is the more stronger acid. Student, more is the polarity of the OH group, more is the acidic strength. That is the first point. Second point, how the polarity will increase? By dragging the density or by donating the density? Very simple. If you drag the density, then oxygen start to drag the electron density from the hydrogen. So withdrawing groups are there, polarity of the OH group increases. Donating groups are there, polarity of the OH group decreases. Based on that one, we will conclude it has lower acidic strength. These two have the higher acidic strength. Among these two, which one has a higher acidic strength? Students, here NO2 is a large minus I effect than this one. Students, here is nitrogen, here 2 more oxygens, here only 2 hydrogens. So the resultant effect of NO2 group is a more withdrawing than the NH2. So on the basis of this one, the X is more acidic, then followed by Z, then followed by Y. X and Z are minus I effect causing groups, Y is a plus I effect causing group. Among the X and Z, the groups are NO2 and NH2. NO2 is a strongly withdrawing group. Stronger is the withdrawing group, more is the acidic strength. So acidic strength order is X greater than Z greater than Y. This is simple about the alcohol acidic strength. Now we enter into the phenols and compare the alcohols. Students, now I am again starting with the alcohols. Here I want to compare the acidic strength of alcohols versus phenol, and I am going to explain how the phenols are acidic and what is their acidic strength when compared with the alcohols, and what is the influence of the substituents on the phenols. Take a look. This is the alcohol, this is the alkoxide ion, this is the phenol. When it loses the H plus, it is converted into phenoxide ion. Phenol, when lose the H plus, it is converted into phenoxide ion. Alcohol has no resonance. Alcohol has no resonance generally aliphatic hydroxy compounds are called alcohols. They have no resonance. In alkoxide also resonance is not possible. No resonance is possible. This is the first point students have to remember. And second point is, generally in the alcohols, carbon is sp3 hybridized. In phenols, carbon is sp2 hybridized. In alcohols, OH group located on sp3 carbon. In phenols, OH group located on the sp2 hybridized carbon. Come to this point. When compared with the phenol, alcohols are less acidic. What is the reason? One reason is R group is plus I effect causing group. Phenyl group is a minus I effect causing group. So donating groups will decrease the polarity of the OH bond, and minus I effect causing groups will increase the polarity of the bond. This is the first point why the alcohols are less acidic than phenols. Come to the second point. Alcohol has no resonance. Alkoxide ions also have no resonance. But phenol have resonance. Phenoxide ion also have resonance. But resonating structures of the phenoxide ions will cause more stability to the species. That's why phenol always wants to convert into phenoxide ion. I will explain why, when compared with the phenol, why the phenoxide ion resonating structures are more stable. I will explain. So this is the second point. And third point is, here OH group located on the sp3 hybridized carbon. Here OH group will be located on the sp2 hybridized carbon. So students, whenever the sp2 hybridized carbon is there, carbon electronegativity will increase. Carbon electronegativity increase. Electronegativity increases means withdrawing nature increases. Automatically polarity of the bond will increase. So these are the three reasons I am repeating. One is the alkyl group is donating group, phenyl group is the withdrawing group. Second point is alcohol and alkoxide ions have no resonance, but phenol and phenoxide ions have the resonance, but phenol resonating structures are less stable than the phenoxide ion resonating structures. That's why phenol is eagerly converted into phenoxide ion. In order to convert into phenoxide ion, it readily loses the H+. And third point, in alcohols, carbon is sp3 hybridized. In phenols, carbon is sp2 hybridized. If it is sp3 hybridized and it is sp2 hybridized, both are carbons, but more is the percentage of S character, more will be the electronegativity of the carbon. More is the electronegativity, more will be the withdrawing nature. More is the withdrawing nature, more is the polarity. More is the polarity of the OH group, more is the acidic strength. This is the major explanation. Now we come to the why the phenol and the phenoxide ion, among the phenol and phenoxide ion, which resonating structures are more stable and why. We are going to discuss. All these are resonating structures of phenol. These are phenol canonical structures, and these are the resonating structures of phenoxide ion. resonating structures of phenoxide ion. Resonating structure of phenoxide ion. Resonating structures of phenoxide ion. This is the phenol resonating structures. Students, take a look. From the rules of the mesomeric effect or resonance, when compared with the parent molecule, if the resonating structures have the charge, if the canonical structures have the charge separation, those structures are unstable. This is the phenol. You can consider it as a parent. When compared with this, all the canonical structures have the charge separation. All the canonical structures or resonating structures have the have the charge separation. Whenever the charge separation is there, relatively those resonating structures are less stable. When phenol is converted into phenoxide ion, this phenoxide ion carries 1 unit negative charge. All the resonating structures also carries only 1 unit of negative charge. Here no charge, but resonating structures have charge separation. Here plus, here minus, here plus, here minus, here plus, here minus. So because of charge separation, stability will decrease. But here there is no such charge separation is the first point. And second point is, whatever the charge is there on the parent, the equal charge only will distributed on the resonating structures. So that's why these resonating structures are more stable and these are less stable. That's why phenol want to convert it into phenoxide ion. This negative charge is converted into this one and this pi density converted into this one. You are getting this structure. Here the electron density shifted here, here electron density shifted here, then you are getting this structure. Here this electron density made a pi bond and this electron density shifted there, you are getting this structure. These are the resonating structures of the phenol. Come to here, this electron density made a pi bond, this pi bonded density accumulated at para position. This accumulated density made a pi bond, this density will be converted into at ortho position. And you will convert, this is the scenario and you will get this structure. So phenol resonating structures are less stable. Phenoxide ion resonating structures are more stable. That's why phenol always want to convert into the phenoxide ion. For converting into phenoxide ion, it releases the H+. That means it shows the acidic character. And students have to remember if the OH group or some O minus group is there, their donating capacity will be reflected at ortho and para positions only. Either in the phenol or in the phenoxide ion, their electron donating capacity will be reflected at ortho and para positions. You remember, this is useful to explain the substituent effects on the acidic strength of the phenol. Here OH group is there, it donates the electron density. That donated electron density is reflected mainly at ortho, para, ortho positions. Here also at ortho, para and ortho positions. Now we are going to enter into the what is the effect of substituents on the acidic strength of the phenols. Students, this is the time to discuss the effect of substituents on the acidic nature of the phenol. For that I am taking a different molecules, taking phenol as the parent and different substituents I am taken. So 3 types of examples is taken. This is the one set and this is the second set and this is the third set. Taking the first set, among the first set, how many molecules? Here 4 molecules are there. Which one has a higher acidic strength and which one has lower acidic strength? Take a look. Here this is the phenol. When compared with the phenol, at the meta position methyl group is there. At meta position methyl group is there. Here at nitro group is there. Here at meta position chlorine is there. It shows plus I effect. It shows minus I effect. It shows minus I effect. Generally here there is no such group. So it is a generally phenol. It is not influenced by either plus I or minus I. As per our previous discussion, plus I effect or plus M effect will decrease the acidic strength. Minus I effects will increase the acidic strength. Based on our explanation, this is the weaker acid. After that, this is the stronger acid. After that, these two. Among these two, NO2 is a strong withdrawing group. So this is the strongest acid and this is the weakest acid. So our explanation is 2 greater than, 1 greater than, 4 greater than, and 3. This is the correct order for the acidic strength of the given phenols. I am explaining simply. Plus I effect causing groups will decrease the acidic strength. Minus I effect causing groups will increase the acidic strength. Among these two groups, it is a stronger withdrawing, it is a weaker withdrawing. It is among all these, this is the strongest acid. Among all these, this is the strongest acid. Just wait student. This is the strongest acid and it is the weakest acid. 2 less than, 1 less than, and 4 less than 3. This is the stronger acid. This is the weaker acid. This is the explanation. Come to here. I am taking all the nitro compounds. Here NO2 group is there at ortho position. Here NO2 group is there at meta position. Here NO2 group is there at para position. Here two NO2 groups are there at ortho and para. When compared with the 4 compounds, undoubtedly N is the stronger acid because 2 withdrawing groups are there, no issue at all. Come to KLM. Among the KLM, here at NO2 group, it shows minus M effect and minus I effect. It shows at meta position. From the meta position only minus I effect will operate. Its influence will operate. Mesomeric effect of the OH group is influenced from ortho and para. Just recall the resonating structures of the phenol and phenoxide ion. OH group shows its influence at ortho and para, or indirectly these groups shows their influence at ortho and para. So NO2 group shows its mesomeric effect at OH group from the ortho position. Parallelly, minus effect also operating. But this OH group is influenced by these two positions but not with this position. That's why NO2 group will shows only minus I effect. Come to here, it shows minus M effect and minus I effect. Right? Whenever the minus M and minus I effects are there, minus M effect will dominate. Minus M effect will dominate. So when compared with these three, it is a weaker acid. Among the K and M, which is the stronger acid? As per our knowledge, it has more minus I effect. We are expecting it is a stronger acid. But due to the formation of intramolecular hydrogen bond, its acidic strength a little bit decreases. Automatically its acidic strength will increase. So N greater than M, M greater than K, K greater than L. This is the order of acidic strength of the given compounds. And come to these 4. Here students, OMe, it shows plus M effect, because it has lone pairs, right? Plus M effect. And when compared with the carbon oxygen, electronegativity is more, so it shows minus I effect. Phenol has no such a group. OMe, it is present at meta position. Its influence on this group is only inductive effect, that is minus I effect. Come to this position, OMe, it has a para position. At para position, minus M and minus I effect will operate. Based on these effects, which one is the stronger acid? Plus M effects will decrease the acidic strength. Sorry, here also plus M effect due to the presence of lone pairs. Students, minus I effect groups will shows the more acidic strength. Here plus M and minus I are there. Here minus I only there. Here plus M and minus I are there. If plus M and minus I both are operating, plus M will dominate. Plus M will dominate. Plus M effect, if dominates, its acidic strength will decrease. Its acidic strength will decrease. So among all the compounds, P and S has lower acidic strength. Among the P and S, which is the stronger acid? Undoubtedly, this one is the stronger acid, because here minus I effect will operate. Minus IL effect will operate. Here minus I effect far away from the OH group. It is the stronger acid. It is the weaker acid. So S is a weaker acid than P. P is weaker. These two are under the influence of minus M effect, plus M effect. That's why plus M effect groups will decrease the acidic strength, but phenol have no plus M effect. That's why it is the stronger acid, but it is influenced by the minus I effect causing group. So it is the stronger acid. Among all these two are weaker acids due to the donating capacity, and it has no donating or withdrawing groups, and finally it has a withdrawing group. So this is the order. This is the influence of the substituents at ortho, meta, para positions in the phenols. This is all about. Regarding the next is carboxylic acids and the acidic strength of some hydrocarbons and the compounds which have the ability to form as a aromatic compounds. We are going to discuss in the next session. Thank you very much.